Hello, and welcome to Grade 3. Equivalent fractions is our focus today. My name is Daryl Frost. Welcome.
I'm Barbara Knox. Welcome.
In just a moment, you're going to pause the video and complete your first task related to equivalent fractions. The task is on the next slide, and you can work either by yourself or with a team or your grade level. As you're working through the task, reflect on the 3 questions you see on the slide.
We'll see you back in a few minutes.
So before we take a look at that problem that you just solved, let's take a look here at the progressions with regards to equivalent fractions. Go ahead, Barbara.
I see that there's nothing for kindergarten, so fraction instruction must not begin until first grade.
Barbara, you're absolutely correct. Formal instruction with fractions begins at first grade, where they're partitioning circles and rectangles into 2 and 4 equal sized pieces, moving into second with thirds, fraction notation, and an equivalency begins in grade 3. Here we're focusing on equivalency, and then it moves further into more complicated ideas in grades 4 and 5. Barbara, this slide here I think is very important because it really helps us see the big picture of planning in terms of actions. Here we're focused on equivalent fractions, but what verbs or actions are students using with equivalent fractions?
Well, I think it's really important the explain part of it. They have to be able to explain or make a model to prove why 2 fractions are equivalent.
Justifying it. So it's
Yes.
more than just identifying.
Mhm.
The really thinking, the reasoning comes in with that explaining part of it.
And when I'm looking at those terms, I know that students quite often confuse the numerator and denominator.
Yes.
You have to remember that numerator is the counting number. That's the number of pieces or parts that I'm counting.
So if I'm thinking about 2/3, I'm counting 2 pieces that are of size thirds.
Correct.
And that's important to use that vocabulary, right?
That
And
denominator tells me how many pieces make the whole, and that's going to determine the size of the piece. The more pieces there are, the smaller the pieces will be.
which will help address the misconception. Those are not whole numbers when you're
Correct.
looking at them. They are related in the context of what we just said.
Exactly.
So here is the task 1 where everyone has created, everyone's got fraction tiles in their room, in their classrooms, and they had to determine a fraction that was equivalent to 6/8. So what would you expect to see here?
Well, I think students generally want to make smaller pieces when they're making equivalent fractions, but there are no 16ths, so they're not going to be able to make smaller pieces for 6/8 using the fraction tiles, the fraction bars.
Right. So if they have like a whole, they know what a whole is, and they can develop or build 6/8. What might that look like here? So here I see my 6/8, right?
Correct.
And if I could even have a whole above that to show that that's what one whole is, and they're all these fractions here are less than a whole. And then looking at this, how might you think about, you see those 1/2, 3/4, 2/3, and 2/4.
Well, I'm looking for pieces that are the same size as the 6/8 that take up the same amount of space. And I only see one of those that are modeled that have the same that take up the same physical space as the 6/8.
And which one is that?
The 3/4.
The 3/4. Could I also think about that as distance and almost connect it like to a number line too, like from 0, the starting point, but each of those units is a fractional piece.
And I think too, I'm putting 2 pieces together, 2 of the 8ths together to make one of the 4ths.
And you can see that there. That's another connection.
Correct.
So are there any misconceptions that you think students may have? I know you said about this, they're try to make 16ths. Any other ideas for misconceptions and how to address?
I mean, I think that they're gonna have some, like the 2/3 is pretty close.
Right.
They might think that that one's equivalent because it's almost the same size.
So in terms of an exemplar answer here, a student that says, well, 3/4 is equivalent to 6/8 because it takes up the same amount of space, or the distances are the same if they see this as a linear model,
Hmm.
connecting it to a number line. So those would be some ways for students to explain how they know. What real world connections can students make to equivalent fractions?
Oh, think about I don't know, a pizza or a pie or a cake, and it might originally be cut into 4 pieces, but then 8 people show up. So
What am I going to do now?
I have to be able to make smaller pieces.
Pieces. Yeah. And that helps them to understand then too that as as I have more pieces to make the whole, what is happening to the size of the piece, which is actually in a previous unit, but you still you take that knowledge and apply it here as well with
Mhm.
equivalency. All right. Okay, third grade teachers, time for your second task. Once again, you're going to pause the video in just a moment and you're going to complete the task on the next slide. Reflect on the 3 questions that you see on the slide as well. We'll see you in just a few minutes. So here we are. The task was to create 2 number lines, and I wanted to focus on number lines because I know that students can be on a struggle bus with thinking, I mean, not only with just whole numbers, but now you're thinking about fractions with number lines. So let's take a look here. Here could be an example of what would be an exemplar if we're looking at equivalency between fourths and sixths. We see that 3/6 is equivalent to 2/4. But let's have our conversation around misconceptions here.
Well, one of the misconceptions is that the parts might not all be the same size. For example, if I look at that second number line, the last fourth is a little bit smaller than the other 3/4. So that's
True.
something that we can expect to happen with students.
If it's representational,
Correct.
but if it's like kind of, huge, if they looks very visually different in terms of the size of the intervals or the segments, then we want the kids to be more precise
Correct.
with that showing.
And another misconception that happens is that they start counting the tick marks instead of the actual intervals between those tick marks.
So by that, you mean like a kid could look at that first one, a student could look at that first one and think that instead of it being decomposed into
They
6,
might think it's decomposed into 7 parts because there's 7 tick marks.
that's a common
It is a
misconception.
common misconception.
Because that then goes back to, do they understand it as number line as distance?
Correct.
It's a linear model. Yeah. I think we've kind of covered the big misconceptions there. And then you see the line, and then also just being able to create 2 different number lines and show that equivalency of 2 fractions, of a fraction pair.
Correct.
So here we have 5 of the big misconceptions when we think about equivalent fractions. Certainly, we've talked about the one with you mentioned the one about the number line and counting the tick marks versus
Correct.
the intervals. And we also mentioned that 5th one there about
Understanding
what
the
a numerator and denominator represent. And these like number lines help to understand that.
Correct. I think that first one's really important too, that they'll see fractions, 2 fractions, they don't have any of the same numbers in them, the same digits.
But they're
How
equivalent.
Can they be equivalent if
Three
they don't have?
fifths and 6/10.
Correct. So those numbers are all completely different. How can those be equal?
So then that's where you have to go back to the tools, the modeling. The modeling is hugely important here to make sense of
Correct.
The equivalency. So to recap, we can always talk about CRA, right? With any math concept here with equivalency, starting with those fraction tiles, moving into number lines, and then that reasoning That abstract thinking is the reasoning to understand, and that goes to that explaining.
Right. So if I'm thinking about 3/6 and 1/2, I'm thinking about those two pieces in the halves being cut into 3 parts each.
Yes. Yes.
So I'm mentally thinking about it, but I'm not actually modeling it with representations.
And you can visualize it.
Correct.
Thank you for joining us for another edition of Math Dive in 5 on equivalent fractions.
We'll see you back next time.